So, a reminder before the lesson begins, make sure you're taking notes and you're listening and watching for the keyword or phrase. Let's get to it. Okay, so for lesson 3 in unit 4, we're going to be talking about solving a system of linear inequalities graphically. So again, we've practiced graphing our linear inequalities on the graphing calculator. We've practiced also graphing them by hand. Again, it's very similar. This time we're just going to be graphing 2 linear inequalities on the same coordinate plane. So going back, it's very similar to solving systems of equations on graphically. So you want to solve by graphing. You're going to use either 0, 0 or any point for each inequality in order to figure out the direction you're going to shade in. There should be shading for both inequalities. Again, you want to shade for both inequalities in order to get max amount of points. Solutions will be where the shading overlaps, so the common ground, the intersection of basically the shading areas or the shaded areas. So depending on the question, you're going to choose a point in the solution set, which is your common ground or the shading that is overlapping. And we've practiced this in class, identifying your solution set to test the accuracy. So any point within that overlapping of both of their shadings must satisfy both of the inequalities, basically making both inequality statements true, kind of like what we've been doing when we've been testing which direction to shade in for just a regular inequality or just one inequality. So again, that point must satisfy both inequalities. So it's going to make both inequalities true. So for the first example, I have x plus 2y is greater than 2 and negative x plus y is less than or equal to 4. I have to change my inequalities in order to be able to graph them. So I'm going to have 2y is greater than negative x plus 2. Y is greater than negative 1/2 x plus 2. Again, just solving for my y is going to be greater or less than equal to my slope-intercept form, but for your inequalities. Then I have my y, my negative x plus y is less than or equal to 4. So I have y is going to be less than or equal to x plus 4, and that one's a little bit easier. So we have our 2 inequalities. We're going to graph them both. I am going to change this color so we can easily identify it. All right, so let's graph the first one I changed. I have 2, and I am graphing my slope. Since it's a greater than, I know my line is going to be dotted, and it's not going to be a solid line, so I'm just going to mentally say and write it dotted. And for this one, I'm going to write solid. So this way, when I'm actually graphing, I know not to draw a solid line for at least that one. So my dotted line, my arrows, and then what I usually do is I shade first each inequality, and then I move on to the next one. So this one I'm going to shade. It's going to be greater than. I know my greater than is going to be above the line. So I'm going to make sure I color that in or shade that in. And then I'm going to move on to my next inequality. So I have my plus 4. I have my x, positive slope. That makes things a little bit easy for me. And again, personally, I like to graph my inequalities from end to end of the graph just to make sure that I'm actually closing out all the spots in the coordinate plane, especially when I shade. And here we have a less than or equal to. So we have our solid line. It's going to be less than, so it's going to be below or under my line. So I'm going to shade that part. So we have both inequalities shaded. We have our purple area and our orange area. The area that is overlapping, this is going to be my solution set. And this is where I have said we are going to mark as the solution set with a big S. It's a solution set. Now you can always test if this is true and suggested by taking a point. So I'm going to do 3, 4. And I'm going to substitute it in the original inequalities. So 3 is x and 4 is y. So I have x plus 2y is greater than 2. And that should be true. And we also have negative x plus y is less than or equal to 4. So let's try this. We have 3 plus 2 times 4 should be greater than 2. 3 plus 8 is greater than 2. We have 11 is greater than 2. This is true. Let's check with our other one. Oops. Oh, what did I do? There we go. Weird. Okay. So now we have negative x, which was negative 3, plus 4 is less than or equal to 4. So negative 3 plus 4 will get positive 1 is less than or equal to 4, which is true. So that point, 3, 4, satisfies both the first inequality and the second inequality. So that means we shaded correctly. Let's move on to the second example. Graph this on your own, pause the video and try it. Okay, so the first inequality I am going to convert to y is greater than x plus 3. My second inequality is going to turn into y is less than x minus 5. And I'm going to graph both of these. Okay, so my inequality for my purple is going to be less than. So my shading is actually going to be down here. My shading for my first inequality is going to be greater than my inequality. So it's going to be above my line. So it's going to be over here. So here we have, if you've noticed, we have positive x and positive x with just different y-intercepts. So these two lines are actually parallel. So we have parallel lines. We know that they never intersect each other. What we also can tell about these parallel lines is that their solutions are never going to intersect. There's no crossover with the shading. So here would be a situation just similar to what we have with system of equations, where our system of inequalities do not have a solution. So we have no solution for number 2. There's no solution set, no point that's going to be able to satisfy both inequalities. Okay, moving on to our next example. Pause the video, graph this one on your own, and see if you can come to some kind of solution. Okay, so the first inequality, you're going to get y is going to be greater than negative x minus 4. So this is going to be a dotted line. Then we have our second inequality, which is going to turn out to be y is greater than negative x minus 1. Again, another dotted line. If you notice, we have another set of parallel lines. So let's see what this situation with parallel lines is going to give us. So we have negative 4, and we have a negative slope. Then we have our next graph, which is -1, and our slope is the same. So we have parallel lines, but this parallel line seems to kind of go the same direction in shading because it's also greater than. So here for this set of parallel lines, we actually do have overlap and we do have a solution set. It's going to be right here in this area. And that's important to know because if you look in this area here, this is not considered a solution set because there's no intersection with the orange line. There's a second inequality. Even with your dotted line here for that second inequality, it's still not an intersection of solutions because it's a dotted line. None of these solutions, none of these points are going to actually be included in this solution set. So all of these points here would satisfy both of these inequalities. And if you picked any point here, it would work. All right, moving on to the last example, number 4. Pause the video here, make sure you graph the inequalities, and then we're going to come to a conclusion about what parallel lines, what type of solutions they give us with solving systems of inequalities. Okay, so the first inequality you are going to get y is going to be less than or equal to 1/3 x plus 1. And your second inequality, you're going to get y is going to be greater than or equal to x or 1/3 x minus 1. So let's graph that. And then we have our first inequality, which was +1. Okay, so here our solution set is going to be in this small area here, but it goes that way and it goes that way forever because remember our lines continue moving on and on. If you look at your solution set from the third example, you have all of this as a solution set and it also keeps going this way. So as your coordinate plane gets larger, let's say if we go to +20 and we go +20 this way, it continues to be a solution set and overlap between the two inequalities. Whereas our example number 2, we had no solutions. So with your parallel lines in solving system of inequalities, they're going to be 2 different cases. So parallel lines have 2 different cases. The first one is going to be no solution, as we saw in example 2. And then it will also have infinitely many solutions, which was examples number 3 and 4, because they look a little bit different. So just so you can identify what that infinite solutions is going to look like, you'll be good. And that you know there's 2 different cases for infinitely many solutions for parallel lines. So 2 cases for parallel lines. If you have any questions, make sure you ask me, email me, check the video for your keyword, and I will see you in the next video. Bye.